Hello, this is a short video talking about shetran calibration. You should have received these files. In the shetran model you've got the executables that we use to run shetran. Run 0 is the data files, and then you've got some documents that go with this video. So to run shetran, I go into shetran model, click on start.exe, and I say go to run 00, and then the model folder, and then I'll click on this XML file. So this contains all the parameter values and also these map files that go with it. Everything needed to run a full shetran simulation. So I'll click on this and it will start. It does two stages. First, shetran prepare, which takes those map files and the XML file and produces the input files, and then shetran itself, which takes the input files and produces shetran output files. It takes a couple of minutes. I'm going to stop this and use the data I prepared earlier. So if you go back to run 00 model, you see there's now loads more files in here. You've got all these input files, which are the shetran input files, and then all these output files. The one I'm going to use here is this one, the outlet discharge at regular time step. So this is the simulated outlet discharge every day. If you click on this, see it's not got a huge number of values because I stopped the simulation quite soon. But what you can do, if it's complete, is save them all. Control A, Control C, copy them to the clipboard, and then you can paste them into Excel. So this is an Excel worksheet that comes with this, and you can paste them into here. These are copied to here and then compared to the measured. So this chart shows the results of the simulation if I had completed it. So if you're looking at calibrating shetran, this is the key thing to do. It's look at the measured in blue and the simulated in orange and see what aspects of the simulation aren't going well. In this case, the main problem is the base flow. So during the dry season here, which is summer in the UK, you can see the simulated discharge is much too high. This is over 2 years, so you can see it's much higher this time and during this period here as well. You also see that the peaks are too small. So one way to improve this would be to reduce the conductivity of the aquifer. This will reduce the amount of flow coming out of the catchment during the dry season. Correspondingly, the water table will rise, and so you'll get more peak flows as well. So we'll work out how to change that. So the way to change that is to go back to the original document, the original folder, and do a new run. So copy run 00 to run 01. And within this, go to the model and change the XML file. This is the XML file here. I prefer to use Notepad++. Just copy that over. Okay. So what I'm going to change is this value here, from 5 meters per day to 0.1 meter per day. So this is the aquifer in the catchment. It's the same aquifer throughout. These soil details and the soil map tell you that. This 5 here and here and here, they refer to this soil property here, 5. So what I've done is for all the soil categories within the catchment, I've reduced the conductivity of the aquifer from 5 meters per day to 0.1 meter per day. So I'm going to save that and run the model again with these new values. So go to start.exe again. This time I need to make sure I change the folder. So shetran practical run 1 model. Check the date. This has got the newest date. And so select this XML file and then this model will start with the new changed aquifer conductivity. I'll stop this again and I will go to the one I prepared earlier. So this is the results of having changed the aquifer conductivity. I've pasted the new values into here and then compare the results. And this, you can see, it's much better. It's done two things. It's reduced the base flow and increased the peaks. So compare it with the other one. See, this had much higher base flow and peaks that were too small. And you can see the new one, base flow is right, the peaks are roughly right. So they've done a really good job. Within the documentation there's another few things that you can change to get a much better simulation. So that's all for now. Goodbye.